Hey there, good morning. My name's Stephen Hughes. I'm in the Department of Geology, UPR Mayagüez, and this presentation is for the Puerto Rico Climate Summit in summer 2024. I just want to thank Dr. Jimenez for the invitation to present here and also ask you to excuse my absence as I'm teaching our department field course each day during this time. So sorry I can't be there with the great group that I know is participating. So anyway, this presentation is directed at a general audience, and it's intended to show how we've developed the Puerto Rico Landslide Hazard Mitigation Office here in the UPR Mayagüez campus, Department of Geology. And so it's been a journey essentially starting from 2017 to the present. The big effect in 2017, as most of us know, was Hurricane Maria, and that really sparked a lot of this effort, which has sort of snowballed along the way with a lot of important partners and students and great support from the university, including from our Dean of Arts and Sciences, Dr. Fernando Hughes, who I remember several years ago in an arts and science faculty meeting, sort of gave us all, all hundreds of us in the in arts and sciences, the challenge to go forth with endeavors that would be beneficial not just for the university and research, but for Puerto Rico as a whole. And he inspired us using the example of the Puerto Rico Seismic Network, which he said was established essentially by one professor and one secretary, and has grown into an important office at the island level in Puerto Rico, and also beyond just Puerto Rico, especially for the Northeast Caribbean. So there's a lot of people to thank, and I have been lucky to work with a lot of these partners and students and colleagues along the way, and and we've done I think a decent job so far, but we still got a long ways to go for our to fulfill sort of the plan that you're going to see lay out here. So let me start with Hurricane Maria. I'm going to try to remove my bubble later, but for now, if you weren't here, Hurricane Maria is sort of a watershed moment in a lot of situations, a lot of people's lives, a lot of you know power, water, communications, infrastructure problems were either highlighted or created by Hurricane Maria. It was pretty rough. Just to focus on landslides here, after the hurricane, we all woke up the next morning and we looked around us, and especially people that lived in the mountainous areas of the island, there were landslides everywhere. Mostly soil movements about 1 meter in thickness or depth, and a lot of those soil movements transitioned into debris flows, and those debris flows roared down our smaller order channels and tributaries. A lot of these little creeks we call quebradas, and those quebradas took the sediment into bigger rivers. And like I said, transportation, communication, power, water were all affected by landslides, and also by the sediments generated by the landslides. And so that's sort of where this whole effort really got spun up. We thought about landslides in Puerto Rico before this, of course, but this event really brought it more so to the forefront. And so with a group in the university, a group of students in the geology department, I started working on this idea to create an inventory for all of the landslides across the island. And so, we couldn't visit each one. There were thousands. We didn't know exactly how many at first, but, I put out a call to students in the Department of Geology or any students really to come work on this inventory project. And we used a lot of aerial imagery in addition to many other data sets, and we were able to carry out this inventory. And I think I had a group of about 10 or 12 students, which uh, were instrumental in everything, right? All right, and so here are some examples of the type of images we were looking at. This is a picture of a farm in Utuado, sort of in the middle mountainous area of the island. This is a photograph of that farm before Hurricane Maria. And so I'm going to jump to the next slide. And this is a photograph of the same area after. And you can see all of these barren earth landslide scars. These are the headscarps and the runout locations of different landslides. And so there's, maybe a couple dozen just in this photograph alone. And we were able to look at really high resolution aerial imagery collected by FEMA after the event, Hurricane Maria, and get a really detailed view and make a geospatial inventory of all the landslides that we could identify from that that aerial imagery data set. And so we ended with an inventory of over 70,000 landslides across Puerto Rico. And so this is published. This is the final product of that group of students. And we also worked with folks in the soil survey, the NRCS Caribbean office, and we worked with people in the USGS landslide hazard office. And we produced this data set, and you see it here. This map is showing many, many points, and each point is one landslide headscarp. And so the headscarp is the area where the landslide initiated. And so you can pick whichever area you're interested in across the island and see the distribution of landslide headscarps. And so there are some areas where there's so many headscarps that it's hard to see individual ones on this map. And so with this inventory, we started to sort of investigate what we could do with this product. And so one of the first things we did was we went to many of our freshwater reservoirs in the central mountainous parts of the island. The screenshots I'm showing here are from a graduate student thesis and published paper. And so what Edwin's project was to look at the Lago dos Bocas, which is one of the major lakes that contributes water towards the metropolitan area of San Juan, even though it's sort of farther away. And so we looked at this basin and we looked at where sediments would come from as landslides derived sediment and how it would get into the lake. And so the map on the top left shows the basin of Lago dos Bocas. It shows over 13,000 headscarps that were in this contributing basin of Lago dos Bocas. And what we did is we went to the lake and we carried out bathymetric survey. This was in 2021, and we were able to create a bathymetric model of the lake and compare that to previous surveys that were done before Hurricane Maria. The most recent one that had been carried out was in 2010. And so when we looked at the historical trend of sedimentation and the amount of sedimentation that we saw after Hurricane Maria, we could mathematically determine with a pretty reasonable degree of certainty that the sediment from Hurricane Maria contributed about 15 years of regular or background sedimentation to Lago Los Bocas. So a considerable event, and this sort of highlights the importance of the sedimentation from landslides, which is not usually thought of as one of these immediate landslide hazards, where a road is taken out or a home is affected or something like that. So an important uh, secondary or tertiary effect of landslide in in our mountainous areas. Also, we took the inventory of you know tens of thousands of landslide points, and we started to do geospatial analysis with different types of data sets across the island, including soil, um, slope, geology, curvature, road networks, fluvial networks, land use. And when we did this type of analysis, we were able to see the correlation of different factors with our landslide inventory. And so what we're looking at here is a map of susceptibility index coded by different soil map units. And so this is just one example of how we were able to translate this landslide inventory from this horrible event in Hurricane Maria into um, a metric that we could use to build a modern, high resolution landslide susceptibility model for Puerto Rico. And so the combination of many, many factors with that type of analysis led us to produce this report and this landslide susceptibility map for Puerto Rico. And so this map was published in 2020. This is a map that shows susceptibility to rainfall induced landslides, not necessarily seismically induced landslides. And so this map is available, it's published, and also we've prepared municipality scale maps as well. So the bottom left of the screen, there's an example of the municipality of Mayagüez, and we have it for all the other municipalities of the main island. So we have 76 individual municipality maps. We also have an interactive map that you can zoom in to the neighborhood scale and see susceptibility. In addition, we have this landslide susceptibility guide prepared, of course, in Spanish for residents of Puerto Rico, and it's about 16 pages, and we distribute it to anyone who would like it. And so we always have those on hand. And so this map has also been used to do some additional analysis, not just of physical susceptibility, but also vulnerability to populations. So comparing the physical susceptibility to the distribution of where people live. And so this study that was highlighted by El Nuevo Dia was carried out by a colleague and some other partners that I work with, and it showed that um, more than 1 million people are living in or very near areas of high, very high, or extremely high landslide susceptibility. And so that's an important distinction between the physical susceptibility and the social vulnerability. Okay. All right. And so a lot of this sort of got spurred by Hurricane Maria, but we also had other events that highlighted landslide susceptibility in Puerto Rico, including 2020 magnitude 6.4 earthquake and many, many aftershocks. And so just from the main shaking events around early 2020, January and February of 2020, there were around 300 or more rock falls, mostly in the South Coast limestone bedrock units, because that's where the highest shaking was. And so we've worked with the seismically induced landslides as well. And then more recently, about a year and a half ago, we experienced Hurricane Fiona and also quite rainy season after or around Hurricane Fiona. And so we know that we had um, around 1,000 landslides that we were able to to catalog from that event as well. And so these combined events and the different groups that we've worked with along the way have led us to increase our capacity at the island scale and to develop new techniques. And one of those is something that I'm going to highlight here, which we call the Puerto Rico Landslide Forecast Network. And so this landslide forecast network is a system that relies on a mixture of monitoring station data and rainfall forecast information to predict when and where in Puerto Rico landslides caused by rainfall may be more likely. And so this is an evolving effort, and one of the important parts of this is a network of monitoring stations where we monitor soil moisture conditions. And so the images you see here are showing one of our monitoring stations. This is the station in Maricao, where we have above ground rainfall uh, measurement, and then we have a suite of sensors in the ground, including soil moisture, soil suction, and groundwater pressure. And all of those are connected to a data logger that is in this white box, and that white box also includes a modem where we can access the data in essentially in real time, or what some might call near real time. And so we measure every 5 minutes at each one of our stations the soil moisture conditions at different levels. So we measure at 4 different levels in the soil, and our goal is to measure down to the base of the soil, because like in Hurricane Maria and Hurricane Fiona and many other events, we've seen that these landslides that are most common occur right along the base of the soil. So this is our distribution of stations right now. We have 18 stations across Puerto Rico. Um, this is the densest network of these types of stations in any jurisdiction of the United States. So the the stations are designed based on USGS um, standards or station design. In some other jurisdictions, some states have one or two or maybe three scattered around, and so we have a relatively small island, and we have at the moment 18 stations and plans for at least a couple more. This is what some of the stations look like. These are two of my students, Gabrielle and Ednet, when we installed the Añasco station. When we install a station, we look for steep terrain. We try to avoid, you know, infrastructure that may alter or won't give us representative uh, readings or measurements for an area. And so we really use our stations as a gauge for an area in general. So we try to pick a site for each station that will be representative. Here's another example. This is our station at Junta, so you can see some of the types of locations where we install our stations. At each station, like I mentioned, we're collecting data every 5 minutes, and then that data is reported uh, to our office computer, and then we prepare graphics that are posted online. So if you go to derrumbe.net, you can find um, the most recent data for each one of our stations. And so this is just an example of data from the Naguabo station during the end of 2022. And so we could take data from those stations and analyze it in a statistical method to develop both cumulative rainfall and antecedent soil moisture metrics that define thresholds for landslide induction for each station and each soil type. And so we're getting enough data now where we can actually do this. And so this is an example, once again, from our Naguabo station, where the yellow lines would be the different thresholds for when we think landslides are more possible. And so if we look back at that Naguabo data, I can highlight in this red box the Naguabo station and then the Hurricane Fiona event. And we had essentially a proof of concept of this approach where we don't have an operational product at the moment, but we are able to share the information with our community partners there, and they took the initiative to move certain people from different areas, and then sometime later a landslide came down um, in their community, covered the road and covered a house, and luckily no one was hurt or killed by this event, but essentially showed how our system is uh, a viable product that we could actually turn into something operational. And so, like I said, you can see all of our data online at the page derrumbe.net. You can see each station, more specific data, or you can see sort of the island scale information. This picture's from earlier this morning. Today's June 3rd when I'm recording this. They also take our data and they talk about it on the news, especially when they want to talk about landslides or flooding impacts with certain rain events. And then, in order to make our network more automated, we have a prototype of a 1-day forecast product, and so we're running that experimentally during the first half of 2024 so far. And so what we do is we use weather, the rain forecast, and we use our soil saturation and some specific thresholds that are preliminary to establish where we think there's moderate, high, or very high probability of landsliding around each one of our stations. And so in February of this year, we did have an event that was uh, strong in terms of rainfall. And so the bottom right map shows our 1-day forecast based on the rainfall predicted and our soil saturation conditions before the event. Um, Turns out the amount of rainfall uh, didn't get to as much as was forecasted. There was not as much rain that actually fell, but places where it did rain considerably, according to the forecast, like our Calle station, circled in red on both maps, we did see some landsliding, which is the photograph you see on the right side. And another thing, and I'm finished here, is to mention we do have another initiative that's more community driven, which is connecting with municipalities, especially emergency management offices. And so we call this Landslide Ready, which we have adapted from other names like Storm Ready or Tsunami Ready. And so that's it for me. Thank you so much. Hope I didn't go too long. If you want to look up any of our reports from the different events that I discussed, that's at the Gear Association website. We also want to thank different funding agencies like the Puerto Rico Science Trust, the NOAA Caribbean Climate Adaptation Network, NSF Collaborative Center for Landslide Geohazards, and the United States Geological Survey Landslide Hazard Program. And so here's some photographs of students that have made all of this possible. I can't celebrate them enough. Here's some more. And that's it. So we'll soon be up and running with the Landslide Hazard Mitigation Office in Residence 4B on campus in UPR Mayaguez. Thank you so much.